Sathyabama Institute of Science and Technology.
Dear all, this is Dr. S.M. Indhumathi from the Department of Biotechnology, School of Bio and Chemical Engineering, Sathyabama Institute of Science and Technology. I am here today for a presentation on the topic organs of the immune system. So to begin with, the lymphoreticular system usually is made up of two components, the lymphoid system and the reticuloendothelial system. We concentrate more on the lymphoid system here, and so we proceed on with that. The lymphoid system usually comprises of several cells and organs, and they are classified based on the functions they perform. The lymphoid organs are basically classified into two types, the central or the primary lymphoid organs and the secondary or the peripheral lymphoid organs. The central lymphoid organs include the thymus, bone marrow and bursa of fabricius, while the secondary lymphoid organs include the spleen, lymph nodes and MALT. So thymus, the central lymphoid organ, the primary central lymphoid organ, as you can see an image of thymus here. So thymus actually starts to develop from the 3rd to 4th pharyngeal pouches from the 6th week of gestation when we are inside the mother's womb. And thymus reaches its maximum size when we become 12 years of age, and it starts to involute rather than growing after that, which means before puberty the thymus reaches its maximum size and later on it does not grow. Thymus actually is the first lymphoid organ to become predominantly lymphoid. So it is located basically in the upper part of the sternum and it has two lobes. The stem cells from the fetal liver, yolk sac and the bone marrow cells usually reach the thymus to mature there for the production of T cells or the T dependent cells. So as I already said, the thymus is the thymus comprises of two lobes. One lobe is given here as an image. As you can all see, the lobe of a thymus is actually covered by a fibrous capsule from which septa penetrate into the lobes, dividing the lobes into several lobules. And you can see a cortex and a medulla here, which means there is an outer cortex and an inner medulla. The cortex is usually rich in actively proliferating immature small lymphocytes, while the medulla region is rich in mature lymphocytes. Alongside the mature lymphocytes inside the medulla region, we have aggregates of epithelial cells, and they are called as Husserl's corpuscles or thymic corpuscles, as you can see here. So the major function of thymus is the production of T-dependent cells for the active proliferation of the T-dependent cells. In early times, thymus was actually identified to be an organ of no function, but later on it was a scientist named Good in the year 1954. He identified that from a patient who had thymoma, and this patient with thymoma was actually suffering from immunodeficiency. So he was able to relate both of the conditions, which finally came to a conclusion that if a person who has been having a cancer in thymus, or if thymus is removed, in such cases the person will be immunodeficient. And later on only it was able to people were able to know that thymus is an organ which is completely responsible for providing cell mediated immunity. And inside the thymus, the cells are actually educated to know the process of immune competence, which means they learn how to show the cell mediated immunity. When they are inside the thymus, they acquire an antigen on their cell surface called THY, which means Thai antigens, and the cells that mature inside the T cells, the cells that mature inside the thymus are called as T dependent cells or T cells. And the T cells usually when they are in the thymus, they are not able to show their immune competency, so they have to reach the peripheral lymphoid organs like spleen and lymph nodes for their further action. They usually reach the white pulp of the spleen, while they reach the paracortical areas of the lymph nodes for further cell mediated immune defenses. The bone marrow. So bone marrow is basically, as I told in the previous video, they are spongy cancellous tissues that are present inside the medulla region of the bones, usually dark red in color. This is in case of adults. We have two types of bone marrow, yellow bone marrow and red bone marrow. Yellow bone marrow is usually found in younger children and infants because they have not complete production of hemoglobin inside them, and they have not so much of RBCs, while adult bone marrows are usually dark red in color, as we have mature RBCs inside us. And this bone marrow is actually the site of development of hematopoietic stem cells, from which they start to proliferate and they reach the other areas for maturation, and they contribute to humoral or cell mediated immunities. Coming to bursa of fabricius. Bursa of fabricius is actually a bone marrow equivalent present in birds. Like how bone marrow serves as a site for B cell proliferation in humans, the same way bursa serves as a place for B cell proliferation in birds. They are usually present in the dorsal part of the cloaca of the birds. Cloaca is nothing but a region that is found near the anus and genitalia of birds. This bursa becomes to maximum size in just 15th day of embryonation, and they start to reach their maximum size in just 2 to 3 weeks, and they start to involute further on. Again, the same way, the fetal liver stem cells, the yolk sac cells, as well as the bone marrow cells, they start to enter the bursa of fabricius so that they mature there and they produce antibodies for providing humoral immunity. The cells from the bursa actually has to reach the peripheral organs to provide, and in fact they have to mature there and they start to produce antibodies only when they reach the peripheral organs. So in case of B cells, they actually reach the medullary cords in case of lymph nodes, while in case of T cells, they usually reach this paracortical areas of the lymph nodes. While this B cells, they reach the germinal centers and mantle layer in the spleen. So immune competency is given by bursa to the birds in stages, which means in just 14 days of embryonation, the birds are able to produce IgM antibodies, but on day 21 only, the birds will be able to produce IgG antibodies. This indicates if a bird is bursectomized in between the 14th and 21st day, the bird will be actually be rich in IgM antibodies but not IgG antibodies. So if a bird is bursectomized, which means bursa, if it is removed from the bird will be completely immune deficient. And this was actually discovered by two scientists called Glick and Chang, who identified that chickens, when they are bursectomized and they were challenged with bacterial antigen, they were not able to produce antibodies and prove their immune competence. Coming to the peripheral lymphoid organs, the lymph nodes. Lymph nodes usually travel along the lymphatic vessels. They drain into each and every part of the body. They also are surrounded by a thick fibrous capsule. It is evident from here. And they have, as we had septa in thymus, the same way we have something called trabeculae, which penetrates into the nodes, separating the nodes into several interconnected compartments. And we have an outer cortex and inner medulla here also. The outer cortex is usually rich in lymphocytes and dendritic macrophages, while the inner medulla region is also rich in lymphocytes and dendritic macrophages, but as elongated branches, and they are called as medullary cords. I've already said that medullary cords are the region where the B cells actively proliferate, mature and start to produce antibodies, and so this area is called the medullary cord area, where the region is B cell rich, and this region is called as B cell dependent area or T cell independent area. And we can see line like structures, small hyphen like structures. This region is called the paracortical area, which lies between the cortex and the medullary cords, and this is the region which is rich in T cells, and this region is actually called as T cell dependent areas. You can all see a thick fibrous capsule around it and the trabecula, and you can all see a germinal center here where the B cells mature to produce antibodies. They are also found in medullary cords, as I said earlier, and we have cortical follicles, and we have afferent lymphatic and efferent lymphatic vessels. Afferent lymphatic vessels are those which takes up the fluids from the bodies for the lymph to filter it, while the efferent lymphatic vessels are the way exit, which means the filtered particles from the lymph nodes will actually exit via the efferent lymphatic vessels. The actual function of lymph node is to filter the lymph. Alongside, they do phagocytosis, and it is the site of active proliferation of T cells and B cells. Coming to spleen. Spleen is the largest of all the lymphoid organs, which indicates that they are much bigger than thymus, bursa, bone marrow, lymph node and everything. So the spleen is usually again surrounded by a capsule where the trabeculae descends to separate the spleen into several compartments. You have a splenic artery, as it is evident from here, which travels along the trabeculae and it separates itself into central arterioles. The central arterioles project itself and reach the white pulp area of the spleen. Why do we call it white pulp? Because we have so many WBC cells rich in that particular area, and in the white pulp area we have so many smaller lymphoid cells, aggregates of lymphoid cells present, and this is called as Malpighian corpuscles. Like how we had Husserl's corpuscles in thymus, the same way we have Malpighian corpuscles in spleen. So as you can all see, the splenic artery runs into the spleen and they separate themselves into central arterioles. Like it looks like a plant with different branches, and this part is the white pulp of the spleen, which is rich in WBC cells. And I already said this region is actually rich in T cells, and this is the T cell dependent area of spleen. And the smaller round cells include, they actually show you what are Malpighian corpuscles. And the splenic artery don't stop with the white pulp, they extend itself to the red pulp region also. It is called red pulp because the region is rich in RBC cells. Following an antigenic stimulus, the germinal centers inside the spleen start to develop. So I've already said germinal centers are nothing but a place where the B cells start to mature and produce antibodies. The germinal centers are usually surrounded by a layer of lymphoid cells, and this layer is called as mantle layer. So this germinal centers and the cells surrounding it, the mantle layer, actually are sites of B cell maturation, proliferation, and this is the site where the B cells start to produce antibodies to provide humoral immunity, and this is the B dependent area or B cell dependent area of spleen, but white pulp is the area which is called as T cell dependent area. So the actual function of spleen, they serve as a graveyard for effete red blood cells. Effete red blood cells means dead cells or damaged or destroyed RBC cells. They come into the spleen, they get completely degraded there. Alongside this function, spleen also serves as a settling bed for filtered blood. Coming to the last one called MALT, mucosa associated lymphoid tissues. So we have mucosa in every lining of our body, in every organ. So everywhere this mucosa is seen, we have certain sets of lymphoid tissues that contributes to the immune defense of the body. These mucosa rich areas where we have lymphoid cells are actually rich in both phagocytic cells, that is macrophages, as well as the T cells and B cells. The mucosa associated lymphoid tissue is the most common name that is given to all the tissue that is present in the mucosa, but we have different sections in this MALT, like we have CALT, which is called conjunctiva associated lymphoid tissue, which protects the eyes. We have vulvo-vagina associated lymphoid tissues, VALT, and we have SALT and NALT. NALT indicates nasal associated lymphoid tissues. We have BALT, bronchus associated lymphoid tissues, and so on. So as you can see a clear picture of spleen here, it has a capsule which has trabeculae entering inside it. This is splenic artery which forms the central arterioles, reaches the white pulp, which also reaches the red pulp. These are germinal centers, this is a mantle layer, and this is a trabecular vessel, and this is a B cell dependent area, and this is the T cell dependent area. So that's all about the peripheral lymphoid organs. So these are my references, the textbook of microbiology by Ananthanarayanan and Panikkar, and I've taken few pictures from online sources as well. Thank you students for patiently watching this presentation. Thank you.